when we're given a problem like this, solve a system of equations, what does that mean? Well, it means what values of x and y make both of these equations true. So we've done this in a few different ways in the course so far. We've done it with graphing, by actually graphing both of these lines, and we see where the point of intersection is. And we've also done it by elimination. In this lesson, we're going to learn a third way called substitution. You might like this way. A lot of people find it easier than elimination. So first of all, just to check, so let's just see what this looks like to graph it. So I've actually graphed here in Desmos the first line, 2x plus 6. And we know we would also be able to graph this by hand, right? If we started at the y-intercept and then used the slope. But let's just graph the second one in Desmos as well, just to see what the solution should be. So we can put this in, y equals negative 3x plus 5. So negative 3x plus 5. There. So remember, what does it mean to solve a system of equations? It means to find the point of intersection where those lines cross each other. And if we look on this graph, it's hard to see, it's a little bit hard to see, but that is the point of intersection, right? That is the point where they cross. So negative 0.2 and 5.6, that seems to be the solution. So how could we do this algebraically without having to graph it? Because if you tried to graph that by hand, it would be very difficult to get an exact answer, right? So that's what we're going to do. We're going to do this algebraically and try to get an exact answer. So with substitution, the way it works is like this. We realize that this is the x value and y value that makes this equation true. And it will work if I plugged in negative 0.2 and 5.6 into both of these equations. It would make them both true. So the thing we got to keep in mind for substitution is that this y and this y are going to be equal to each other, right? At our solution. That makes sense, right? Because the y values are going to be equal. So if the y values are going to be equal, we can make this equation equal to this equation because they're both equal to y, right? So we could just write 2x plus 6 is equal to negative 3x plus 5 because those y's are equal. And then this is just an equation we know how to solve, right? And we can solve for x. So that's what we're going to do. The trick to these types of equations is to get everything with an x on one side and everything with a number on the other side. I usually like to try to get everything with an x to the left side just to make it a little bit easier, just to give myself a little bit of a process. So first of all, I want to put this negative 3x on the left side. So I do that by adding 3x, right? So I'm going to add 3x and I'm going to add 3x. And when I do that, these 3x's are going to cancel out with each other. So all I'm left with on the right side is now 5. But I also want to move this 6 to the left side, right? And I'm going to do that by subtracting 6 and subtracting 6. So that's going to get rid of these. And if I look at what's left on the left side, it's just going to be a 2x plus 3x, which is 5x. And on the right side, all that's left is a 5 minus 6, which is negative 1. Okay, and now we want to solve for x. So x is now being multiplied by 5. So the way we get rid of that 5 is we're going to divide by 5, right? It's going to make those go away. And x is going to be negative 0.2 if we do that division. There we go. So that is our value of x. So does that match up with the solution that we got? Yeah, we did. Right, it does. The x over here was negative 0.2, and that's what we got for our x. So we're on the right track. Okay, so now we can find y. How do we find y? Well, similar to elimination, once we found one variable, we can just plug it back in to one of the original equations to find the other variable. In this case, it's actually pretty easy because both of them have y equals. So all we need to do is, so I'm going to plug x equals negative 0.2 into, which equation looks simpler? I think the first one, equation 1, looks simpler because it doesn't have a negative. So y equals 2 times negative 0.2 plus 6. And if I do that on my calculator, I am going to get 5.6. So, is that right? Yeah, that looks right based on the graph. So my solution to this system of equations is negative 0.2, comma 5.6. That is the final solution. Okay? So that's the whole process. That is substitution, right? You plug one equation into the other, you set them equal to each other, you solve for the first variable, and then you just plug it in to solve for the second variable. Okay? So what I want you to do here is pause the video, try the your turn question yourself, see if you can figure it out, unpause when you're ready to see the solution. Okay, so there is the final solution. X is 0.6 and y is 6.8. So I'm just going to write that out. Solution is 0.6 and 6.8, right? There you go. So hopefully you got the same answer. If you didn't, go back and check your algebra. So it's really not that much more complicated than the processes we've been doing so far. What I want you to try now is there's a bunch of practice problems, these try it yourself problems. And there's actually more substitution practice problems at the end as well. These last ones are a little bit tricky. So only try these once you've finished all the other questions, these 6 questions here. You'll notice the answers are here. Well, this one's down here, but the rest of them, they're all on the right-hand side. So you should be getting those answers. If you're not getting those answers, you probably did something wrong. So go back and check your work or ask the teacher. Okay? So give those a shot. When you're really comfortable with that, you can try these challenge problems out at the end. Okay? Good luck.